lockdown, I've been looking and watching the coronavirus data grow, and I started to wonder what causes coronavirus to act the way it does. And it's a virus, so it's a exponential growth, which eventually turns logistic. Just about everything that grows at an exponential rate eventually becomes logistic because of a limited supply. There's a carrying capacity. There's lots of variables involved. So started looking at the logistic curve and how does a logistic curve fit what we're looking at. So we're looking at a maximum number of cases, the steepness of the curve, and then the midpoint at which the curve will start to bend. So what I did here was created a list of the data that's been put out there, including the data from today, the 26th. We're currently at 104,000 cases in the United States, and started to decide, let's see what kind of a lesson I can make with this. So what we've got here is a logistic curve with an unknown carrying capacity, that's a maximum, unknown steepness, and an unknown midpoint. So how could we figure out what these points are? So if you can click on any one of the points, you can see the coordinates of that point. So the thing is to try to figure out, well, which one of these points is the midpoint? The midpoint is at which the curve stops growing at the rate that it was before. So previously it grows at a similar rate, and then that rate starts to decrease, and that's when the bend happens. So just by looking at the curve, we're already over 100,000. So let's say we go to 150,000 cases. And we assume a growth rate of 0.3 and a midpoint. We say the midpoint is 60 days since the first case. Now we can see we're pretty close. We're shifted over a little bit. So we could increase the number of days. We could go 64 days. 64 days tends to look pretty good, but the growth rate doesn't quite match. So I can play with the growth rate. And then I can start asking about this maximum number. The maximum number, if we assume, is coming from that midpoint, we can figure out at which point what the maximum number of cases should be. So I'm just going to move this over and get rid of a couple of numbers. Looks like it should be somewhere, if you double the 68,000, somewhere around 140,000. So what's another way we can look at this data? Another way we could look at this data is if we look at the exponential growth part of it. If we want, we can start looking at the exponential growth by defining a new variable. I'm going to call it the log of cases, LGC, semicolon equals. That's just my syntax for how we're going to define this variable. So I want to take the natural log of cases. So I take the LGC of cases, and now I'm going to add to the table here. I'm going to add the log of the cases so that we have a table of it. Now what I want to do is I want to graph that information, create a scatter plot of it. Let me highlight the whole C and then do a scatter plot. Now my scatter plot's in green. So what I'm going to do is I'm going to scroll down here. I'm going to separate out the green graph just by grabbing it and dragging it to an open space. It's separated. Now I'm going to adjust the green graph so that I can look for the point at which the growth no longer matches what it used to. So here I am from -10 to 100, and it appears to not go at the same rate. Notice how it starts to go linear, and then it stops going linear right at this point here. So we're looking about day 64. Day 64 would give me that number there. So if I double that number, I should get a pretty good estimate of when it's going to happen. So day 64, we're looking at approximately 140,000 cases at a growth rate of about 0.3. So We can adjust the growth rate if we would like to make it a little less steep or a little more steep. To find a curve set that appears to give me a good estimation of what's going on here and how long this epidemic could potentially last and how many people it could possibly affect. Again, these are just estimates. These are just numbers. This lesson is out there for students to try out, give it a whirl, understand a little bit about pandemics, exponential growth, turning logistic. Give it a whirl. The lessons are all set, ready to go.